Magandang araw! I hope everyone who is watching this video is safe, healthy, and happy. So today we shall have a presentation on the rules of inference. So we shall try to have exercises on how the rules of inference is used in proving arguments. Okay, so the objectives of this presentation are for us to be able to identify the rules of inference and use the rules of inference as justifications in formal proof. So as I mentioned earlier, we shall have exercises on the use of the rules of inference. So for exercise number 1, we are to supply the missing statement. So we have here two propositions. So the first proposition is P implies not Q. So we are given P implies not Q, and then we have P, and then we are asked to use modus ponens on propositions 1 and 2, or premises 1 and 2. So remember modus ponens, P implies Q. If you have P, then you have Q. Okay, so you have P implies not Q, we have P, and therefore we will have not Q. Okay, so the answer is not Q when we apply modus ponens to 1 and 2. Next, we have the conditional not P implies Q. We have not P, and then we are asked to use modus ponens on premises 1 and 2. Again, recall the formula for modus ponens. We have P implies Q. If you have P, then Q exists. Okay, and therefore the answer would be Q. Okay, so if you have not P implies Q and you have not P, then you have Q. Next, we have the conditional not P and Q implies Q and not R. And then we have not P and Q, and we are asked to apply modus ponens to premises 1 and 2. Note that in the formula P implies Q, P and Q are variables and they could be anything. So in our particular example, this whole thing is our P and this whole thing is our Q, such that P implies Q and we have P, and of course we know that Q exists, such that the answer is Q and not R. Okay, so again, this is P implies Q. We have P, therefore Q as the answer. Next, we are asked to apply modus ponens on not P and Q implies not Q and not R. We have not Q, and not R. So remember the formula for modus tollens. You have P implies Q, not Q, and therefore the answer should be not P. So what is not P in this particular example? So we have this, no? Because this whole thing is our P, this is our Q, and then we have not Q, therefore this is our not P. Next, we apply hypothetical syllogism to premises 1 and 2. So our first premise is not P and Q implies not Q and not R. Not Q and not R implies Q or R. Remember, the formula for hypothetical syllogism is like a transitive property. You have P implies Q, Q implies R, and therefore P implies R. So in this particular example, this is our P. P implies Q, Q implies R. So we would expect that P implies R as the final answer. And we have that. This is our P, this one, and this is our R. So P implies R. So that's our answer. Next, we are to apply conjunction to premises Q and not R. So that's the first premise. The second premise is Q or R. So take note that we should use premise 2 first. So it's like P and Q with the second premise as our P. So what's the answer? So we have Q this Q or R. So this is our P and Q. Okay? So you have Q or R. So 2 because it appeared first here. So it should be our first variable in our formula P and Q. Okay? So you have Q or R and Q and not R. So the idea is we should be faithful to the formula. No? Kung ano, bali, hahanapin mo kung ano yung values ng P, Q, R, S doon sa given argument. At yun ang isa-substitute mo. Yung mga values na yun, ang isa-substitute mo, isa-substitute sa variables P, Q, R, S. In our particular example, we need the variables P and Q. No? And in this number, P is Q or R, and Q is Q and not R. Okay? And then we have the conjunction of two conditionals, not P implies Q, and S implies R, not R. And then we have not P or S, and we are to use constructive dilemma. Remember the formula for constructive dilemma. If you have P implies Q and R implies S, if you have P or R, then you have Q or S. Okay? So in our particular example, this is our P, P, Q, R, S. We have our P or R, therefore our answer would be Q or S, which is Q or not R. Our Q is also Q and our S is not R. So that's our answer when we apply constructive dilemma to premises 1 and 2. Okay, so for exercise number 2, we are to state the justification for each line that is not a premise. Okay, so we are given these two premises, A and B implies A implies D and E. Second premise, A and B and C, and we would want to have this conclusion B or E. So we are given the proof. We are just to identify the rules of inference used so that these are inferred from the given premise. Note that A and B is here is just simplification. So since this is a conjunction, by simplification we can get A and B. And A and B is the P here. So you have P implies Q, you have P, therefore Q. So this one will be allowed to, we will be allowed to have this as our Q. And then again, A is here. This is a conjunction, and therefore by applying simplification, we can have A. And again, A is P in this expression, where D and E is our Q. So you have P implies Q, you have P, therefore Q. Okay, again, by applying simplification, D and E, we will have D, and by addition, we will have D or E. Okay? So that's the answer. Again, we simplified the second premise. So since this is a conjunction, we can simplify to get this. By applying modus ponens on 1 and 3, so this is 1 and this is 3, we can have this. No? We will be allowed to have this as our Q. By applying modus ponens to 1, 3. Again, simplification of number 3, we will have A. Applying modus ponens to 4 and 5, we will have D and E. By simplifying again, number 6, we will have D. And by addition, we will have D or E. Then we have this another example. So we have Y implies M and N implies R, N or Y, and therefore we will have R or Y and M. We have Y implies M, which is actually the simplification of number 1. And then Y implies Y and M is absorption, applying absorption of number 4. And we will have this, which is actually a conjunction. We have N implies R, which is our premise number 2. And Y implies Y and M is actually number 5. So we apply conjunction to 2 and 5 to have number 6. And then by applying constructive dilemma, okay, we will be able to get this, no, applying constructive dilemma to 6 and 3. Okay, so again, simplification of number 1, we will have the fourth statement. By applying absorption to number 4, we will have statement number 5. Applying conjunction to premise 2 and 5, we will have statement number 6. And by applying constructive dilemma, we will have the desired conclusion. Letter C. So we have statement A implies B. Second, C implies D. The third statement is not B or not D. Not A. A implies F, implies C, and therefore we have the conclusion not E implies F. Number 6 obviously is a conjunction of premises 1 and 2. So we just combine premises 1 and 2. So we get statement number 6. Then by applying destructive dilemma to 6 and number 3, we will have number 7. By applying disjunctive syllogism to 7 and 4, so you have not A or not C, you have not A, therefore you will have not C, or P or Q, you have not P, therefore Q. So that's the formula for disjunctive syllogism. And finally, for number 9, we were able to get the conclusion by applying modus tollens to number 5. Okay? So again, we have conjunction of 1 and 2, destructive dilemma of 6, 3, disjunctive syllogism of 7, 4, and modus tollens of 5 and 8. We have another example. We have G implies H implies I if and only if J. K or not L implies M. We have G implies H or not K. We have N implies L implies M. And we have not I if and only if J, with the desired conclusion not N. So number 6, we are able to get number 6 by applying modus tollens to 1 and 5. Okay, so you have P implies Q, you have not Q, therefore not P, which is statement number 6. Number 7, we have not K. This by applying disjunctive syllogism, you have P or Q, you have not P, therefore Q. In our example, not Q is not K. And then number 8, not L or M by applying disjunctive syllogism. So K or not L implies M, you have not K, therefore you will have not L implies M. And finally, for number 9, we apply modus tollens to number 4 and 8. So we have not N. Okay, so you have 1, 5 modus tollens, 3, 6 disjunctive syllogism, 2, 7 disjunctive syllogism, and 4, 8 modus tollens. And finally, we have this H implies I implies J, K implies I implies J. We have not H and not K implies not L or not M. Not L implies not N, and not M implies not O. We have P implies N and Q implies O, and we have finally not I implies J, and the desired conclusion not P or not Q. So not H is applying modus tollens to 1 and 6. 8 is applying also modus tollens to 2 and 6. And then 9 is just conjunction of 7 and 8. Number 10 is applying L and M here. L and M is applying modus ponens to 3 and 9. And number 11 is applying constructive dilemma to 4 and 10. And finally, the desired conclusion is by applying destructive dilemma to number 5 and number 11. So here's the final answer. 7, 8 conjunction, 3, 9 modus ponens, 4, 10 constructive dilemma, and 5, 11 destructive dilemma. So I hope you are able to have a clear grasp of the application of the rules of inference. Till next time, class. See you when I see you. Stay safe.